Hi guys, Daniel here. Hope you're doing well. Hope you guys are studying hard as we get closer and closer to the start of the exams. So today we've got paper 2 of the Edexcel GCSE Maths Higher paper, calculator of June 2023, so last year's paper. And having done the solutions to this paper, there were definitely some tricky questions in there. There was a very weird probability question, which was only 2 marks, but it took me a while to explain. There was a ratio problem. I think that was question 23, and question 24 with the octagon was very, very tricky. But you guys will see as you guys watch the video. Yeah, just like with paper 1, you will have the timestamps in the description, so you can easily access whatever question you'd like. If you don't want to watch the whole thing, it's not a problem at all. And yeah, that's pretty much it. So let's get into it. Okay, so question 1 says we need to work out the value of 25 minus the square root of 43.87 divided by 6 plus 2.1 all squared. Write down all the figures on your calculator display. Okay, so this is very, very simple. So all you're going to do is just get your calculator and then just plug in all of the values. So I'll start with a fraction bar. I've got 25 minus the square root of 43.87. I'm going to divide this by 6 plus 2.1 all squared. So just double checking that's the exact same. Yep, that's fine to me. So I'm going to click equals and I get this here. So all I'm going to do is I'm just going to copy all of the figures down and see what I get. So it's going to be 1 point, let me just double check, 765, and then again it's 27923, 27923. And that's it for part A. Part B says we need to work out the value of the reciprocal of 0.625. Now remember, the reciprocal just means 1 over your number. So in this case, all you're going to do is 1 over 0.625. Punch this into the calculator and see what it gives you. I'll do it here. So we just bring this up a bit. 1 over 0.625. And this gives us 8 over 5. So therefore the answer is just 8 over 5. I'll put it here. And that is question 1 finished. Okay, so question 2 says we need to write 60 as a product of its prime factors, and this is 2 marks. So this one is very, very simple. Just going to start with a factor tree, and then you're going to get 2 branches. I'll start with 2. This will be 30, and then this will break down to 2 and 15. This will break down to 3 and 5. Now, once you've finished your factor tree, the ends of the branches where you have the prime numbers are going to be your factors that you multiply. So I'm just going to circle these, circle this, circle this, circle that. The answer is just going to be 2 times by 2 times by 3 times by 5. And then what you can do is just simplify this using index laws. 2 times 2 is 2 squared, so it just becomes 2 squared times by 3 times by 5. And that's it. And that's question 2 finished. Okay, so question 3 says there are 48 counters in a bag. There are only red counters and blue counters in the bag. The number of red counters to the number of blue counters is in a ratio 1 to 2. Helen has to work out how many red counters are in the bag. She says there are 24 red counters in the bag because 1 is half of 2 and 24 is half of 48. Is Helen correct? You must give a reason for your answer. So it's only 1 mark. What I would do with this type of question is essentially just work it out and see if it's the exact same as what she's saying. So how do we work out ratios? Well, we know that I'm going to write here. We've got R to B. We know it's in the ratio 1 to 2. And there are 48 counters in total. So what we can do is add these 2 parts together, 1 plus 2. This gives us 3 parts. And those 3 parts, this has to equal the 48 counters. So I'm going to say that 3 parts, right, is equal to 48 counters. And then to get 1 part, right, we're just going to divide by 3. So this is a calculator paper, so you can use your calculator. But 48 divided by 3, which will give us 1 part, is just equal to 16. So there are 16 counters, which represents 1 part. And if we look back at our ratio, that is for red, right? So we can see that there's actually 16 counters for red. So you could just say Helen is incorrect. Helen is incorrect. Correct. As there are 16 red counters. 16 reds, not 24. And obviously that would mean that there would have to be 16 times 2, right? Which is equal to 32 blue counters. So that would be the split between red and blue in this ratio. So yeah, you just work it out and that will give you the answer. And yeah, that's question 3 finished. Okay, so question 4 says we've got n and that's between -2 and 5, right? Where -2 is included and 5 isn't. And it says that we need to write down the greatest possible value of n. Okay, so with this inequality, what it's telling us is that, well, -2, I'll do it here. -2 would be included, then -1, then 0, then 1, then 2, then 3, then 4. Now, 5 isn't included because there's no line underneath. So we can't include the 5. So therefore, the greatest possible value of n would be 4. That's it. Now, part B says, on the number line below, show the inequality of m being given between -4 and 1. Okay, so again, with these types of questions, we can see that the line is underneath this inequality here, meaning that 4 is included. So -4. So I'm going to go to -4, which is right here, and I'm going to draw a circle, but I'm going to fill it in. This closed circle means that we are including -4, and then we're going to do it all the way to 1. So I'm going to draw a line like this. I'm going to go all the way to 1, which would be around here. And then as we can see, 1 isn't included because there's no line there. So I'm going to just draw an open circle there, like that. And this is our answer. This tells us that m can be -4 at its lowest, or it can just be less than 1, not including 1. And that will be it. That's part B. And then now part C says we need to solve this. 2/5 g minus 4 is less than 6. Okay, so let's do this one. Now, firstly, we need to get g on its own. So I'm going to move this -4 over. So I'll get 2/5 g. Sorry, I wrote 2 over g. Apologies. 2/5 g. 2/5 g. And then I'm going to move that -4 by adding 4. So it'll be 10, right? If I add 4 to both sides, I'll just say add 4, like that. And then I'm going to times by the 5 to get rid of the 5 there. So it's going to be 2g is less than 50. And then now I'm going to divide by 2 to give me g is less than 25. So therefore, g is just less than 25. And that's the answer. And that will give you the full 6 marks for question 4. Okay, so question 5 says, here is a triangle and a rectangle. We've got the base to be 8 and the height to be 6x for the triangle. We've got the base to be 5 and height to be 4x minus 1 for the rectangle. It says all measurements are in centimeters. And the question says that the area of the triangle is 10 centimeters greater than the area of the rectangle. And we need to work out the value of x. Okay, so firstly, they've asked us to work out the value of x, meaning that we need to solve an equation. Secondly, we've got this sentence here, a statement, right? The area of the triangle is 10 centimeters greater than the area of the rectangle. Now, this question is just a typical algebraic worded problem whereby they give you a sentence in English and it's your job to translate this sentence in English into a mathematical equation. And in that way, you'd be able to figure out what x is. So let's go ahead and do that. First part, what I'm going to do is I'm going to highlight parts of this sentence here. So the first part I can see, which is significant, is the area of the triangle, right? Which I'll highlight in yellow. Okay. Now, the next part I can see is this word is, right? And then after that, I've got 10 centimeters squared greater than, 10 centimeters squared greater than, and then the last part is the area of the rectangle. So what I need to do is figure out each of these in terms of mathematical expressions or symbols and put it into some sort of equation, right? So firstly, I'm going to start with the first part, which is the area of the triangle. Now, we know that the formula for the area of a triangle, right, is just base times height divided by 2. Now, in this case, we can see that the base is equal to 8 and the height is equal to 6x. So what I'll do is I'll just do it. I'm just going to write I'll write AOT like this for the area of the triangle. This is going to be base, which is 8, times by 6x divided by 2, isn't it? Tidying this up, this will give me 8 times 6 is 48, so this will be 48x. And I'm going to divide this by 2 to give me 24x. So therefore, I can say that the area of the triangle is 24x. And I'll just highlight this in yellow just to show that this corresponds to that first part of the sentence. Now, next part of the sentence is that word is. Now, they're saying that something is something else, right? That word is the same as equals, isn't it? Right? So I'm going to just say that is, right? This just represents an equal sign. So I'm going to highlight that in green. And that will represent that part of the sentence. Now, the next part is 10 centimeters greater than. 10 centimeters squared greater than, sorry. The area of the triangle is 10 centimeters squared greater than the area of the rectangle. So what we can do, let us just piece this together so far. So this part here is 24x. I've got 24x here. And then the is equals. And then now we've got 10 centimeters squared greater than the area of the rectangle. That just means that we figure out the area of the rectangle and then we just add 10 to it, right? Because the area is 10 more than the area of the rectangle. So what we can do maybe to help us out a bit more is let's work out an expression for the area of the rectangle. And we know that this is just equal to the base times the height. base times height. And in this case, the base is equal to 5 and the height is equal to 4x minus 1. So what I'm going to do here is I'm going to write here, I'm going to say AOR for the area of the rectangle. This is just going to be 5 multiplied by 4x minus 1, isn't it? Then I can just expand this bracket to give me 20 x minus 5. And this here will be the area of the rectangle. So I'm going to do this here. And I will put this right here. So I'm going to have 20 x minus 5. Now I'm going to highlight this. Actually, no, I'll leave it like that. So that's fine. And then the last part, remember, we haven't done it. The part in blue is 10 centimeters squared greater than. Well, if you're 10 more than the area of the rectangle, then all that means is that you're just adding 10. So essentially, what we have now is an equation from this sentence in English, right? So I'm going to highlight this in yellow just so it's super clear, right? This part is that part there, and then this is the is, and then this part is the 10 centimeters squared greater than, right? Remember, these are areas, so that's why it's just 10 centimeters squared, it's just 10 here, and then we've got this part here. So essentially, remember, they've asked us to solve or to work out the value of x, meaning that we have to solve an equation. And we've formed this equation now, and this will give you a couple of marks. So now we just need to solve it. So firstly, let us simplify. So I'm going to write it one more time, just because the highlighter can be a bit distracting. So 10 plus 20x minus 5. And then now, firstly, simplifying the right-hand side, I've got 10 minus 5, which is just 5. So I can write this as 5 plus 20x, like this. And I've got 24 here. Now we need to get x. I'm going to move this 20x over to the left. So if I minus 20x on this side, like this will just give me 4x is equal to 5, isn't it? And now to get x, we just divide by 4. So it's just going to be 5 divided by 4, which is just equal to 1.25, isn't it? So x is just 1.25. And that's it. And that will give you how many marks? That will give you 4 marks. Okay, so question 6 says, last year a family recycled 800 kilograms of household waste. 57% of this waste was paper and glass. It says the ratio of the weight of paper recycled to the weight of glass recycled is 12 to 7. And we need to calculate the weight of glass the family recycled. Okay, so this is not too bad. So firstly, we've got 800 kilograms of recycled household waste. And we know that 57% of this is paper and glass. So what we need to do first of all is figure out what 57% is of this 800 kilograms. And that is what we're going to use to split this ratio. So I'm going to do this here, 800 kg. And remember, this is a calculator paper, so you can do this very, very easily. You're going to change this to a decimal. So 57 divided by 100 would just be 0.57. We know that of means multiply. And then we're just going to times this by 800. So I'm going to put this into my calculator and see what it gives me. So I'm going to do 0.57 times by 800. And this gives me 456. So I'm going to say 456 kilograms. And this is either paper or glass. Now, we know the ratio for paper or glass is 12 to 7. So what we're doing essentially is we've got 12 to 7 here. And we're going to add these two parts together. I'm going to do 12 plus 7, which is equal to 19. So we've got 19 parts in total, and that must represent the 456 kilograms. So what we're going to say is that we're going to have 19 parts, and this is going to equal 456 kilograms, like this. And let me just rewrite this because that was very, very bad. Parts. Perfect. Okay. So now, whenever you figure out a certain amount of parts, you always just figure out what one part will represent, right? So I've got one part here. And I'm going to clearly just divide by 19 on both sides, isn't it? So I'm going to do 456 over 19. 456 over 19. This gives me 24. So one part must represent 24 kilograms. Let me just put divide by 19 here. And divide by 19 here. Now, the question asks us to calculate the weight of glass the family recycled. We can see that the weight of glass represented 7 parts. So all we would need to do is just work out what 7 parts represents if one part is 24 kg. So we're going to do 7 parts, right? And quite clearly that just means we just times by 7, don't we? So the answer is just going to be 24 times by 7, whatever that is. And I'll put this into my calculator. 24 times by 7 is equal to 168. So therefore, the amount of kilograms recycled for glass, would be 168. So just be 168. And that's it. And that will give you the 3 marks for question 6. Okay, so question 7 says a number D is rounded to 1 decimal place. The result is 12.7. Complete the error interval for D. So this one is very, very simple right now. This comes up a lot, especially with boundaries as well. And there's a couple of ways to do it. What I like to do is I like to draw a little table. So, for example, I'm going to just put a table here, put a table here, put a table here, and then I'm going to label this in terms of units, right? So I'm going to put ones here, right? This is one's unit, and I'm going to call this one. I'm going to put tenths here. This is just 0.1. This is hundredths. This is 0.01, and then thousandths, and so on and so forth, right? Now, whatever they're asking you for in terms of decimal place tells you which column you go to in this table. Now, since it says one decimal place, it means that I'll look at the one with one decimal place. And all you're going to do is just half that number. So 0.1 divided by 2 is going to be 0.05. And then what you would do to complete the error interval is you're just going to add and subtract this number from your original number, 12.7. So in this case, if I do the lower bound, right, low, right, this will be 12.7 take away 0.05, and this is just going to be 12.65, so that will go there. And the other one, the upper, I'll do it right here, upper, this is just going to be 12.7 plus 0.05, and that is just going to be 12.75, and that will go here. And that's your answer essentially. Another thing you can do as well is, I'll do it here, I've got 12.7 like this. If I put a 0 here, it becomes 12.70, and then now you can just add 5 to give you 12.75 like this, and then you can just take away 5 like this, and that will give you 0.65. And then you've got 12 here, and then 12 here, and then you get the exact same thing. So however you prefer. But yeah, that's question 7, and that's it. Okay, so question 8 says Tamsin buys a house with a value of £150,000. The value of Tamsin's house increases by 4% each year. Rachel buys a house with a value of £160,000. The value of Rachel's house increases by 1.5% each year. At the end of 2 years, whose house had the greater value? You must show how you get your answer. And this is a 4 marks, I believe. Yes, 4 marks. So what you want to do with this one is, this is just pretty much compound interest, isn't it? So I'm just going to write the formula here. So you're going to have your value at the end of however many years. It's going to be equal to P, your principal amount. You multiply this by 1 plus, and then R is your interest rate over 100. And then this is to the power of N, which represents the number of years, right? And this is for compound interest because I've got a plus here. But if it was depreciating, if it was decreasing, it will be a minus instead of it. So you can kind of think of this as plus or minus. But I'll put a plus here just because we can see it's increasing. So in Tamsin's case, or Tamsin, right? What will her value be? Well, we can see quite clearly. Well, the principal amount, the amount she starts with is 150,000. And then I need one more zero, don't I? And then I'm going to do 1 plus the interest rate is R, which is 4%. So I'm going to just put a 4 here. R equals 4 over 100. And then this is to the power of how many years? We need it after 2 years. So I'm going to put 2 here. So all I'm going to do is punch this into my calculator and see what it gives me. So let me get rid of this. Get rid of this. Let me just move this to the side a bit here. And this will give us 150,000 multiplied by 1 plus 4 over 100 to the power of 2. So I get this here, and then we get 162,240. And this is how much money Tamsin has at the end of 2 years. Now we just got to do the same for Rachel. So I'm going to write T for Tasman here. I'm going to write R for Rachel now. So same thing. It's going to be V is equal to, and then it's going to be 160,000. 160,000, and it's going to be 1 plus, in this case, R is 1.5 this time. So 1.5 over 100, and then it's still to 2 years. So I'll put this here, and then now I'm just going to put this into the calculator, see what we get. So this will give us 160,000, and then this is going to be 1 plus 1.5 over 100 to the power of 2. And this gives us 164,836. 164,836. And now you can see quite clearly Rachel has a larger amount of money, so Rachel's house will have a greater value. So you just say Rachel has Rachel's house has the greater value, I should say. Actually, Rachel's house has the greater value. And that's it. And that is a question 8 finished. Okay, so question 9 says the cumulative frequency table gives information about the ages of 80 people working for a company. We've got the ages on the left in the columns, and we've got the cumulative frequency on the right. Part A says on the grid opposite, draw a cumulative frequency graph for this information for 2 marks. Okay, so what I'll do is I'm just going to screenshot the table here, and I'm just going to put this on the page underneath here. So this is the graph that we need to use. So I'll just put this here. And then now essentially whenever you're dealing with a cumulative frequency graph that you need to sketch, right, or plot, all you're doing is you're just treating the uh upper boundaries of your class intervals as your pretty much your x coordinates, right? And then these here, your cumulative frequencies as your y's essentially. So what I'm going to do is I'm going to start with the first one, which let me just move this here. So the first one is 30 and 20. So we're essentially going to plot 30, 20. So I'm going to do this here. So 30 is right there, 20 is right there. So that will be fine. And then the next one is going to be 40 and 48. 40 and 48 is going to be, it's going up in fives. It's going to be right here. That's fine. And then what do I have? I've got 60, I've got 50 and 64 I need to plot. 50 and 64, which is going to be right here, like this. And then I've got 75. I've got 60 and 75, sorry, 60 and 75, which is going to be right here, like that. Whoops, let me just do it a bit better. Be right here. And then the last point is 70 and 80, which is going to be right here. Now we've got our points. You're just going to draw a smooth S through these points, aren't you? So hopefully I'll be able to do it on this graphics tablet. It's not too bad, but I'll try my best anyway. That there. I'm sure you'll be better than mine. So let me do it one more time, actually. I'm going to draw a smooth S. I'll stop like this. I'm going to just smoothen it out like this. And then continue like that. And then this one going to be like that there. And then I'll just join it like this. Like that. So it will pretty much look like this. So that is done. And then that was 2 marks. And then part B says we need to use the graph to find an estimate for the median age. And remember, the median is your middle value. There were 80 people working for this company. The median will be the middle of that, which is half. 80 divided by 2 is 40. So what you're going to do to find, what is it asking us for? Asking us for estimate for the median age, is you're just going to go to 40 on your cumulative frequency axes and then see what that takes you to. So I'm gonna put it in green here. So 40 is right here. And then that will take me right here. And I'm just going to go down all the way here and see what value that is. This. And that is just 1 after 35, isn't it? So it's just 36 here. So therefore the answer is up here, isn't it? The answer for an estimate for the median age would just be 36 years. And that will be part B, and that will be the entire of question 9 finished. Okay, so question 10 says a biased dice is thrown 60 times. The table shows information about the number that the dice lands on each time. So we've got the number of dice from 1 to 6, and we've got the frequencies for each number. Now it says Gethin throws the dice twice. We need to work out an estimate for the probability that the dice will land on 6 both times. Okay, so firstly, what we need to do is work out the probability that it lands on 6 once, right? And that's not too bad. So we're going to say probability of lands on 6. And then we'll just use the table. Well, how many times did it land on 6 in this 60 times? Well, it was 15, isn't it? So it'll be 15, right? And then out of how many times it was thrown? 60 times. So it's going to be 15 out of 60, which actually simplifies to 1/4, doesn't it? So the probability of it landing on 6 is 1/4. Now, we're throwing it twice. So what we're actually working out is the probability of the dice. I'm going to write lands on 6, right? And, can you see I'm writing and in capitals? It lands on 6 again. Now, whenever you're dealing with probability, you should remember that and just means multiplication. So all we're going to do here to work it out is we're just going to do the probability of it landing on 6 times the probability of it landing on 6. So it's just going to be 1/4 times 1/4, which is just 1/16. So your answer is just 1/16 here. And that's that for part A. Now, part B says Sally is going to throw the same dice n times and record the number it lands on each time. She will use her results to work out a more reliable estimate for the probability in part A. What can you say about the value of n? Okay, so remember with these types of questions, right, you're dealing with some sort of investigation or experiment, right? And you're trying to work out certain probabilities, and you do the experiment a certain number of times and you get some information. Now, what you should always remember is that the more times you do this experiment, the better your estimate will be. So if Sally is doing the same experiment, she's throwing the same dice n times, right? And she wants a more reliable estimate for the probability, then the number of times that she throws it has to be more than the number of times that Gethin threw it, right? Because it was thrown 60 times, 60 times. So what you could say about n is that n has to be bigger than 60. So all you have to do is just say that. So I'm just going to say here, n must be bigger than 60. For example, let's say n is equal to 100. That will be that will give you a better estimate for the probability. And yeah, that's it. That's question 10 finished. Okay, so question 11 says we need to use algebra to solve the simultaneous equations 2x plus 6y is equal to 5 and 3x minus 4y is equal to minus 12. Okay, so this one is very, very straightforward, right? You're just using the column method. So we've got two variables, x and y's. We want to make we want to make one of them the same number, right? What I'm going to do is I'm going to look at the x's. I've got a 2 and a 3 here. So I need the LCM of 2 and 3. LCM of 2 and 3, that is just 6, isn't it? We can just times them together. 2 times 3 is equal to 6. So essentially, what that means is that I want to make this 2x a 6x and make this 3x a 6x. So I'm going to label this equation 1. I'm going to label this equation 2. And, well, to go from a 2x on the top to a 6x, I will need to multiply the whole of equation 1 by 3, wouldn't I? So I'm going to do equation 1 times by 3. And if I do this, let me just rub by this. It's a bit confusing or distracting. I'm going to do 2 times 3, that will give me a 6x here. And I'm going to do 6 times 3, which is 18, so that'll be plus 18y. And I'm going to do 5 times 3, which is 15. So that will be the first equation done. We've times everything by 3, and we've got this equation 6x plus 18y is equal to 15. And then for the second equation, well, we have a 3x here. We need to get it to a 6x, so we're going to times by 2. Times this by 2, and then if I times this by 2, 3x times 2 is 6x. Minus 4y times by 2 is going to be minus 8y. Got minus 8y here. And then equals, and then we've got minus 12 times by 2. That's going to be minus 24. So these are going to be our two new equations. But what's helpful is is the fact that we've got the 6x's. The 6x's are the same now, right? So what we're going to do now is just take these away. I'm going to take this away, take this away, take this away. 6x take away 6x is 0. So I have a 0 here. Then I've got 18y minus 8y. You've got to be very, very careful. When I'm doing these types of questions, I will just write it out just to be safe. So I've got 18y minus and then minus 8y. We know that two minuses make a plus. So it's actually 18y plus 8y, which is just equal to 26y. So therefore we have 26y here, like this, and then this is equal to 15 minus 24. Again, two minuses. I'll do it right here. 15 minus 24. That's the same as 15 plus 24, which is just 39. So therefore, we've got 0 plus 26y is equal to 39, meaning that we can figure out what y is quite easily. Let me just zoom in a bit. So that means that we've got 26y is just equal to 39, meaning that y is just equal to 39 over 26. And I'll just put this in my calculator to simplify it. 39 over 26 is equal to 1.5, 3 over 2. Yeah, so we can say that this is just equal to 1.5 or 3 over 2, whatever you prefer. Now that we've got y, we can plug this back into any of the equations to figure out what x is. Now I'm going to start with the first two because these have smaller values of x and y, and I'm going to plug it into the first equation. Why not? So I'm going to write that the first equation again. I've got 2x plus 6y, and this was equal to 5, I believe. Let me just double check. Yeah, 5. And then we know that y is 1.5. So we're going to say that we've got 2x plus 6 lots of 1.5 is equal to 5. So I'm going to plug that in. 6 times 1.5 is equal to 9. So I get 2x plus 9 is equal to 5. I'm going to move this 9 over by subtracting. So I have 2x is equal to 5 take away 9, meaning that 2x is equal to minus 4. And we just divide by 2 to get x, and that will be minus 2. So therefore, we've got y is equal to 1.5, and we've got x is equal to minus 2. So therefore, we could just put this here. Minus 2 for x, 1.5 for y. And that's it. And that will give you the 4 marks for question 11. Okay, so question 12 says the points A, B, C, and D lie on a circle center O. A, B, C, D is a rectangle. We've got the rectangle inside the circle. It says AB is 8 centimeters and BC is 10 centimeters. And we need to work out the circumference of the circle. We need to give our answer to 3 significant figures. Okay, now firstly, they're asking us for the circumference of the circle. We need to know the formula for the circumference of the circle. And I'll just put this here. The circumference of the circle, there's two formulas for it. There's either pi d, so pi times the diameter, or you can use 2 pi r. So either one of these formulas is perfectly fine to use. So let's continue to see what happens. So for us to be able to answer this question, we see that based on the formulas, we need the diameter, right? Or the radius, and then times it by 2. So we need either one of those. Now, how do we go about doing this? Now, for me, firstly, when I see this question, they've told me that ABCD is a rectangle, right? Meaning that this angle here is 90 degrees because it's just the corner of the rectangle. And now we know that the center is O, and we can see there's a point A and a point C, right, on the circumference. If I draw a line from A through the center, which is O, all the way to C, that would be the diameter. Remember, the definition of the diameter is just a line that goes from one point of your circumference to another, but it has to pass through the center. So what we can do here is say, well, fine, I'm going to draw a line A to C. We're going to start here. I'm going to make it go through O. So I'll just straighten it up a bit. This here. And this is going to be our diameter. So all we would need to do essentially is just work out what D is, right? Plug this into here, and then we're finished. So how do we do this though? Well, we've got, as we can see, by drawing that line A to C, let me just straighten up a little bit more. We've got a right angle triangle, don't we? We've got a right angle triangle, and we've got two of the sides, 8 and 10. So we could use the right angle triangle ABC to figure out D by using Pythagoras. Plug that into the circumference formula pi d, and that will be our answer. So let's go ahead and do this. So I'm going to do it here. So we've got that right angle triangle, which I'll do here, like this. And then we know this is 8, I believe. Is that 8? That's 10. Yeah, so this is A, this is B, and this is C, and this is a 10, right? And we're looking for D. And we can just use Pythagoras' theorem, which states that if I have A squared plus B squared, this is equal to C squared. So what I'm going to do is label. Now, remember, C is always a hypotenuse. So I'm going to say C is equal to D in this case. I'm going to say this is A. I'm going to say this is B. Now, if I plug in everything into this, then I'll do it right here. This will just give me 8 squared plus 10 squared is equal to D squared. 8 squared is 64. 10 squared is 100. So I get 64 plus 100, which is 164. So I've got 164 is equal to D squared. To get D, I need to square root, don't I? So I'm going to do 164 square rooted, and this will give me D. So I put this into my calculator. See what it gives me. I get root 164. And this is 2 root 41. So I can say D is equal to 2 root 41 in third form. Yeah. Now remember, the question asks us for the circumference of the circle, which we know is equal to pi d from there. So therefore, the circumference is just going to be C is equal to pi times this number here, 2 root 41. And I'll just put this into my calculator and see what it gives me. So pi times 2 root 41. This gives me, whoops, I need to put the bracket on the outside. This gives me 40.232 blah blah blah. The question asks to have it to 3 significant figures, so that will just be 40.2, isn't it? So the answer is just 40.2 centimeters, and that's it. And that's question 12 finished. Okay, so question 13 says ABC is a triangle, and we just need to calculate the size of angle BAC correct to 1 dp. They've given us an angle of 70 degrees and 2 sides. Now, whenever you see this type of question, it's definitely trig. They're asking you for a size. They're asking you for the size of an angle. So whenever you're trying to figure out a size of an angle or a length, it's always going to be either one of the sine rule or the cosine rule when you're dealing with a non-right angle triangle. So what I'm going to do first is I'm going to label the angle, which is what they're asking for. So angle BAC, which is this one right here. So I'll call this X. And I need this angle here. Now, how do we know whether or not which one to use in terms of its sine rule or cosine rule? Well, let's see what we've got here. I've got an angle here, which I know, and I've got the corresponding side, right? And I've also got this side here, right, which is 15, but I don't have this angle. I'll call this Y. So what I can use is say, well, fine, I've got this angle here and I've got this side. I've got this side, but I don't have this angle. I've got 3 out of 4, right? I've got 3, so I've got the angle I've got this side here and I've got this side, and the fourth one is the y. When you have 3 out of 4 options, right, you could use the sine rule to work it out. So what we're going to use is we're going to use the sine rule to work out what this value of y is here. And then once we have that, we know that angles in the triangle add up to 180. So we can just add that to 70 and then take it from 180, and that will give us x. So let's go ahead and do this. So if I use the sine rule, now remember, we're trying to find an angle, by the way. So you're going to use the angle version of the sine rule formula, right? So do this here. It's going to be sine of that angle, y, divided by that corresponding side, which is 15. And this will equal sine of 70 degrees. And then divided by 18. And then what I can do is just multiply by 15 to get sine y. So sine y is equal to sine 70 over 18 times by 15. And I put this into my calculator to see what it gives me. So I'm going to do sine 70 over 18 times by 15. And this gives me 0.783077. So I'll say sine y is equal to, I'll just say it again, 0.783, blah, blah, blah. And I'm going to write dot, 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 so the examiner knows I'm not rounding. And now to get y, we're just going to do the sine inverse of that, isn't it? Sine inverse of that number there. Blah, blah, blah. And then I'll put this into my calculator. So I'm going to do sine inverse of that. So do sine inverse of answer. And this gives me 51.543. 51.543. Let me just double check this here. Yeah, that's fine. So in that case, we now know what this angle is. It's 51.543, and we need this angle x. So all we need to do to find x is add these two angles together and take it from 180. So I'm going to do this here. So I'm going to say x is equal to 180 minus those two angles. So minus the 70 degrees that we know, 70 degrees, and I'll have to add that angle there as well, 51.543, blah, blah, blah. And I'll just put this into my calculator and see what it gives me. So it's going to be 180, take away the 70, and I'm going to add that angle that's already given in my other answer. So I just click answer here, put this in, and this gives me 58.456, blah, blah, blah. And it wanted it to one decimal place. So that will just be equal to, let me just check again, 58.5, isn't it? So it'll be 58.5 degrees. And that's it. That's question 13 finished. Okay, so question 14 says, show that x squared minus x divided by 2x squared minus 5x minus 3 can be written in the form ax plus b over cx plus d, where a, b, c, and d are integers. Okay, so firstly, we've got an algebraic fraction, right? Now, this algebraic fraction is quadratic because we've got powers of 2. And apparently, this quadratic fraction can be written in the form of something with powers, with x, which has powers of 1, right? So essentially, what we have here is a quadratic expression, and then this is a linear expression. Now, the only way that's possible is through simplification. So this is just a simplifying question, essentially. And how do you simplify algebraic fractions? You factorize, see what factors are common top and bottom, and then just cancel them out. So essentially, all we need to do is just factorize the top, factorize the bottom. There will be a common factor, we cancel them, and then we'll have our linear factors. So let's go ahead and do this. So I'm going to start with x squared minus x minus 6. Now, how do we factorize quadratics? You look at your last number here, which is a negative 6. Notice that I'm highlighting the minus as well. That's part of the number. You ask yourself, what are two factors of this number which add to make the number in the middle? Now, there's just a minus here, but that's just the same as a minus 1, isn't it? So we're looking for two factors of minus 6, which add to make minus 1. And that is going to be, that will be negative 3 and positive 2, isn't it? So therefore, we could say then that our factorization, you're just going to put two brackets like this. And then you're going to have an x here and an x here. And that will make the x squared term. And then all you do is just put these two numbers that you found. So minus 3 here and then plus 2. So that would be the first expression factorized, the numerator. Now we need to do the denominator now. Now I'll do it here. I've got 2x squared minus 5x minus 3. Now what do I notice about this one? There's a number in front of the x squared term. So what we need to do is use the AC method, don't we? So we have to times this number at the front with the number at the end. We're going to times these two. 2 times minus 3 is equal to minus 6. So meaning that now we need two factors of minus 6, which also add to make this minus 5. And that's just going to be minus 6 and a positive 1, isn't it? Minus 6 plus 1 is equal to minus 5. And when you times them, you get minus 6. So it's definitely those. So what you're going to do now is you're just going to break this down. You're going to write 2x squared here. And then you're going to rewrite this minus 5x in terms of the two numbers that you know add to make it, which is going to be minus 6x and then plus 1, which is an x, and then minus 3. And then now, what do? You're going to split it down the middle, and you're going to factorize the first two terms. So I'll take out, what can I take out here? I can take out a 2 and an x. So I have a 2x on the outside, and then I'll have an x here. And then what do I times 2x by to get to minus 6x will be minus 3. Then now, we can see here, these two have no common factors. Now, whenever that's the case, when you get to this part of a question and you've got no common factors here, you just take out a 1, right? Because 1 is a factor of everything, isn't it? So I'll take out a 1, and then we would have just the same thing. And then now when we get here, this is something that you should expect. We can see that these two are exactly the same. We can pull this out. So I'll have an x minus 3 here on the outside. So I'll highlight it in yellow. And that will leave us with, if I look inside, I've got a 2x here and I've got a plus 1. That would be the second bracket. So it'll be 2x plus 1, like this. And so now we've successfully factorized both the numerator and the denominator. So we can actually just rewrite this algebraic fraction. So I'll do it here. So I'm just going to do this here. And it will just be, well, the numerator is x minus 3x plus 2, x minus 3x plus 2. And then we're going to just divide this by the denominator, which we know is equal to this, x minus 3 and then 2x plus 1. And as I said before, you'll always get a common factor top and bottom, because that's the whole point. Now we can see quite clearly that we have to cancel the x minus 3. So we just cancel. And this will leave us with x plus 2 over 2x plus 1. And this will be our answer here. And you can just say, well, you don't have to say, unless it says, no, you don't have to say. But this will be our answer. But just to be safe, you could just say a will equal the number in front of x, which is just going to be a 1 in this case. So a equals 1. B will equal 2. C will equal 2 again. And D will equal 1. So this will be our answer here. But again, it's just x plus 2 over 2x plus 1. And that's it. And that will give you the 3 marks for question 14. Okay, so question 15 says, here are the first 4 terms of a quadratic sequence, 3, 9, 17, and 27. We need to find an expression in terms of n for the nth term of this sequence. Okay, so this one may look a bit tricky, but there's a step-by-step process to it. And once you memorize this process, then it's the same thing each time. So let's go ahead and start. So firstly, I'm going to write the sequence out here again. So I've got 3, 9, 17, I've got 27. Now what I'm going to do is I'm going to figure out what the first difference is. So 3 to 9 I add 6, 9 to 17 I'm going to add 8, aren't I? And then 17 to 27 I'm going to add 10. Now that is the first difference. Now what we do now is find the difference between these numbers here. And we can see that this is just a plus 2 here, and this is a plus 2 here. Now once you get this, your second difference, I'm going to label this second difference, right? You're going to divide this number by 2. So it's a 2. We're going to divide it by 2. This gives us 1. Now, this number 1 is key, right? What you do is you're now going to multiply. I'm going to put colon here. We're going to multiply that 1 by n squared, right? And this gives us 1n squared, or just n squared, isn't it? Now, once you get here, this is the first part of your answer. So I'm going to put this here in the answer. I'm going to put n squared right here. Now, what you do when you've got to this step is you're actually going to form another sequence, and it's going to be the values of this expression at n squared. So I'll do it here. So I'm going to have n squared, and then, well, n equals 1 will be the first term, which will be 1 squared, which will be 1. And then the second term will be when n equals 2. 2 squared is 4. So essentially, it's just the square numbers, isn't it? 3 squared is 9, 16, and so on and so forth. Now, once you've got your second sequence, what you're going to do is you're going to put your first sequence, the actual question, on top of this one and then subtract them. So I'll do it right here. So I'm going to do 3, 9, 17, and 27. And I'm going to write this sequence underneath it. So I'm going to do 1, 4, 9, and 16. And then what I'm going to do is I'm going to take these away. And then that will form another sequence. 3 take away 1 is 2. 9 take away 4 is 5. 17 take away 9 is 8. And 27 take away 16 is 11. Now you get a third sequence. Now this sequence is always going to be a linear sequence, an arithmetic sequence. And what you do once you get to this step is you just need to find the nth term of this sequence here. Now, how do we find the nth term of an arithmetic sequence, a linear sequence? Very, very simple. We're going to figure out what the common difference is between each of the terms. So let me actually write nth term here, by the way. Nth term here for this one. The common difference is 3, isn't it? It's going up in 3s each time. So that would be the first part of your answer. So it'll be 3 and then n. So you just multiply the common difference by n. That's the first part. Now the second part is, well, if this is the first term, what would the 0th term be, or the term before the first? And well, that means we'd have to do the opposite and take 3 away. 2 take away 3 is -1. So that number there is what you're going to put at the end. So this is going to be 3n minus 1. And this is how you calculate the nth term of any linear sequence, just doing the same process here. So now we can say we've got the linear sequence, the nth term for the linear sequence, which is 3n minus 1. What you do now to just finish off is you're going to add this onto the n squared, the first part of your answer. So your final answer is just going to be n squared, and then you're going to add on that nth term there. So it'll be n squared plus 3n minus 1. And that's it. And that'll give you the 3 marks. Okay, so question 16 says, the histogram gives information about the number of hours some students used their phones last week. The histogram is incomplete. We've got the frequency density, which is not labeled, and we've got the horizontal axis for the number of hours used. The question says 28 students use their phones for between 30 and 40 hours, and 24 students use their phones for between 40 and 60 hours. And we need to use this information to complete the histogram. All right, so whenever you're trying to complete the histogram, you obviously need to have the frequency density axes labeled, don't you? Now, we don't have that, but they have given us a bit of information. I've got number 1 here, I've got number 2 here. Now, something that you should always remember when you're dealing with histograms is that the area of any bars represents the frequency. So I'm just going to write this here. The area is equal to the frequency. So in this case, they've actually told us for the first sentence, right? 28 students use their phones between 30 and 40 hours. Well, where is that? This represents this bar here. And again, the 28 students is representing the frequency, which we know represents the area. So I can say that this rectangle here just represents an area of 28. And we can actually use this to figure out what the frequency density must be for this bar, and then that we'd be able to figure out the scaling for the frequency density. So let's go ahead and do this. We've got 28 we've got this bar here, which is 28, area of 28. We've got the base to be 30 to 40, right? So to work this out, or this is fine, this is going to be a base of 10. The area is 28. So to get the height, which is represented by the frequency density, and I actually write another formula for you as well, the frequency density is equal to the frequency divided by the class width. This is another formula you need to remember. So in our case, we just need to work out what the frequency density is, and I do it here. Frequency density would be equal to the frequency of this one, which is 28. And I'm going to divide this by the class width, which is clearly 10. So 28 over 10 is 2.8, meaning that this height of this rectangle is 2.8, and that would be just here, isn't it? And that would allow us to work out the scaling for this, because if that's 2.8, then this is definitely a 2 then. This is a 1. So every box goes up in 0.1s, isn't it? So that way, this is just going to be a 3, this is going to be a 4. And from there, we can figure everything else out. So the next question, or the next part of part A, was we need to complete the histogram, right? So we've done the scaling, and then we've got this second sentence here. It says 24 students use their phones for between 40 and 60 hours, which is this rectangle here. So again, we just zoom in. So I'll just do this part here. So for the second sentence, right, I'm going to have a rectangle. I'm going to have a rectangle like this, like that. Let me just move it up a bit so there's room. That. And what do we know about this rectangle? Well, the 24 students, represents the area, the frequency. So I'm going to say the area is equal to 24. And this is from 40 to 60. So 40 is here, 60 here. So that means that the base is going to just be 20, isn't it? Going to be 20. And this here. So the height, or to work out the height, which is the exact same as the frequency density, we're just going to do 24 over 20, which is equal to, just get my calculator, why not? 24 over 20. This is equal to 6 over 5, or 1.2. Yeah, so this is going to be 1.2, meaning that we now know the height of this rectangle that is missing, and which represents the frequency density. So I'm just going to label 1.2 here, which is going to be right here. This is 1.2, and it's between 40 and 60, isn't it? So what I'll do is I'm going to draw a rectangle. I'll use black ink for this, and then ink to shape. So I'm going to draw a rectangle. Obviously, you'll have a ruler. but this software allows me to draw a rectangle nicely. So I'll do it like this here, like that. And what I'll do is I'll just straighten this up a bit. So just move it down. So move it down a bit like that. And yeah, that looks perfect to me. So then what I'm going to do now is I'm just going to get my highlighter and just highlight this in gray. And this here would be the missing bar. And this would be the completed histogram. So that would be part A finished. So we've done that. Let me just be an extra here. I just like to be complete. So that's perfect. Yeah, pretty much that's good enough. Okay, so that's done. Now, part B. What does part B say? It says no student used their phone for more than 60 hours, and we need to work out the total number of students with that information. Okay, so that means that our histogram is complete. If we want to work out the total number of students, again, we just need the frequencies of each of these bars. So how do we do this? It's just rectangles. We're just going to find the area of each of these and then add them together. But we do know that the third one was 28 given to us, and the fourth one is 24. So I'm going to put 24 here because we know that. So we just need to work up these two, which is not too bad. So start with the first one. It goes from 0 to 20 on the base. It's going to have a base of 20. The height goes up to, what is that? If that's 1 point, this is 1.5. This is going to be 1.6 right here, isn't it? This is going to be 1.6 right here. So the area of this one is going to be 1.6 times by 20. 1.6 times by 2 is 3.2. Times that by 10 is 32. But you can just check this on your calculator as well. It's going to be 32 here. This one has a base of 10, as we can see. And the height of it goes up to, this is 3.5. Like this is going to be 3.6. One above 3.5 is 3.6. So the height here is 3.6. So the area of this one is just going to be 3.6 times by 10, which is 36. So now we've got the areas of each of these bars. We're just going to add these together and see what we get. So I'll just get my calculator and do this here. Let me just zoom out a bit so you can see the working too. So put this here. So it's just going to be 32 plus 36 plus 28 plus 24. And this gives me 120. So therefore, the total number of students is just 120. And that is our answer for question 16, and that'll give you the 4 marks. Okay, so question 17a says, show that the equation x to the 4 minus x squared minus 5 is equal to 0 can be written in the form x is equal to the 4th root of x squared plus 5. Now, this is show that question, so we've got to use algebra here. So I'm going to rewrite the equation that we're starting with. So x to the 4 minus x squared minus 5 is equal to 0. Now, whenever you're doing a show that of any type, right, when you're trying to show that you get a certain algebraic expression, it's always important to have a look at what it is you're trying to get to. That way you'll be able to figure out what it is maybe what you need to move and so on and so forth, right? Now, when I look at this expression here, I've got an x squared plus 5 being 4th rooted, right? Now, for me, when I look at what I have, I've got an x squared term, I've got a 5, but they're both negative, right? So essentially, for me, that tells me I need to move these two over. So I'm going to go ahead and do that. I'm going to add both of them to the right-hand side. This will give me x squared plus 5. Now, if I compare, they've got an x is equal to the 4th root. I've got an x to the power of 4. So now I just need to just 4th root, don't I? So I'm going to do x is equal to the 4th root of x squared plus 5. And that's it. And that will give you the 1 mark. So that's done. Let's do part B. It says starting with x naught is equal to 1.5, use the iteration formula xn plus 1 is equal to the 4th root of xn squared plus 5 3 times to find an estimate for a solution of this here. X to the 4 minus x squared minus 5 is equal to 0. And how many marks is this? This is 3 marks. Okay, so whenever you're doing these types of questions, it's always, this is pretty much standard. You've got the part A when you have to rearrange. So essentially, we have this equation that we're trying to solve. We rearrange it to get some sort of formula that we can perform an iterative process on. And then that we'd be able to find estimates for the solution, right? So we have to start with x naught is equal to 1.5. So all you're going to do with this one is you're going to get your calculator, and then we're starting with x naught is 1.5. So you're going to press 1.5 and you're going to click equals, right? This stores 1.5 on your calculator. Now, all you do from here is you're just going to put this into the formula. So I'm going to get the formula here. So I'm going to do shift and I'm going to do that there to get 4. And I'm going to do, we start with 1.5. So I'm going to, instead of putting 1.5 though, I'm going to put answer because remember I stored it. So I'm going to do answer squared plus 5 like this here. And this is the number I get when I plug it in. Now remember, this was x naught, right? So this number here will be x1. So x1 is equal to that number there, 1.6409, 1.6409, and 09017, 09017. This is x1. It says we need to use it 3 times. We've only used it once, so we need to do it 2 more times. And then what you do now is you're just going to click equals. When I click equals, I get the second answer. So this will be x2. I'll put this in. This is 1.6653, 1.6653, and then this is 98002. 98002. This is x2. Now we need to do it 3 times, so we just need to do it 1 more time, x3, and then this will equal, click equals again, we get this 1.6697, 1.6697, and 63088. 63088. So because you've done it 3 times, this answer here would be your final answer. And that is pretty much it for question 17. And as well as that, sometimes, actually not all the time, but they can ask you to give an actual answer, right? A complete answer. And what you'd have to do is just keep clicking equals and see what it approximates to. And as you can see, it terminates here, 1.6707147771. This would be an estimate for the equation that we have here, this equation here, right? But sometimes, most of the time, they'll ask you to do it to 3 times or 4 times and so on and so forth. But if they ask you to do it to, if they just ask you for a general answer, then you'll just keep clicking equals. But yeah, that's pretty much it for question 17. And that will give you the 4 marks, this answer right here. Okay, so question 18 says 2a and 5 to c are in the ratio of 6 to 5, and 4b to 7c is in the ratio of 20 to 21. And it says we need to show that a plus b to the ratio b plus c is equal to 70 to 20 for 3 marks. This question is 3 marks. So what we need to do essentially is just figure out our a, b's, and c's, and then work out what a plus b is, work out what b plus c is, and then make sure we can figure out that it's in this ratio of 70 to 20. So what do we do now? Whenever you see these types of questions, right, where you've got ratios and you've got equations, you've got algebraic expressions, right, what you should always do is express these as fractions, right, which you saw earlier on in this paper. So I'm going to start with 2a to the ratio of 5 to c, right, and this is equal to 6 to 25, right? You can express this as a fraction. If I express this as a fraction, it's just going to be 2a divided by 5c is equal to 6 divided by 25. These mean the exact same thing. But the good thing with this is that I'm going to use algebra to manipulate this just to get a and c on its own. So a divided by c, and that will give us the ratio a to c. So how would I do this? I need to get rid of these 2 and this 5 here. So I'm going to times by 5 on the top and then divide by 2 on the bottom. But when I do this, so for example, if I do a divided by c, right, and this goes there, then when I divide by a number, then you just multiply on the denominator. So it's actually 2 times 25 here. And then this 5 will times with this 6. So it just becomes 5 times 6, like this. And then now tidying this up, this is just the same as a over c is equal to 30 divided by 50, right? And then we can cancel the zeros here. So we can say that a divided by c is 3 over 5. And well, if a divided by c is 3 over 5, that just means that the ratio of a to c is just equal to 3 to 5. Which is good because now we've got a and c's without the multiples, which is easier to work with. Now what we're going to do is we're going to do the exact same thing with the second ratio, right? So I'll do it here. We've got 4b to 7c is equal to 20 to 21. Again, I'm going to express this as a fraction. So I've got 4b divided by 7c, and this is equal to 20 divided by 21. Now what I'm going to do is I'm going to get rid of this 4 and this 7 to get b divided by c, because that will give me b to c. So to do this, I need to put this 4 down here, and that's going to multiply it. Put this 7 up here, that's going to times it here. So it's going to be b divided by c is equal to, the top one will be 7 times 20. And the bottom one is going to be 4 times 21. Like this here. And then tidying this up, this is going to be 140 divided by 4 times 21 is 84. Now, this clearly can be simplified. This is a calculator paper, so what I'm going to do is I'm just going to punch this straight into my calculator to see what it gives me. So I'm going to do 140 over 84. This is equal to 5 over 3. So what we've actually worked out then is that b divided by c is equal to 5/3, meaning that the ratio of b to c is equal to 5 to 3. So now we're here. We've got the ratio of a to c without the multiples. We've got the ratio of b to c without the multiples. Now, how do you do these types of questions? It comes up all the time. What you want to do is you just want to make whatever letter that appears in both the same value, the same number of parts, right? And we can see that they both have a C, right? So what you want to do is you want to make these the same. Now this has a 5 here, and this has a 3. You're looking for the lowest common multiple, right? Which is going to be 15, right? So I'm going to put 15 here, like this. I'm going to put 15 here, like this. Now, how do I go from this 5 to this 15? I have to times by 3, meaning I have to do it with this one as well. So this becomes 3 times 3, which is 9. So therefore, we can say that this ratio is the same as 9 to 15, A to C. And in this one, how do I go from a 3 to a 15? I have to times by 5, meaning I have to times this one by 5 too. So 5 times 5 is 25. So therefore, we can say that B to C is the same as 25 to 15. Now, why is this helpful? Because now the C's are the same, right? Now, once the C's are the same, that means you could just bring them all together. So you can actually see the ratio of A to B to C is actually just equal to, well, what is A? A is 9, right? 9. B is 25, right here. 25. And then C is 15. Right, what I'll do is I'm going to highlight these so it's just clear to see what I've done here. So this one is going to be this one here, like that, and then the B, right, is this one. This is this one right here in the middle, right here, and then the A I'll do in blue, which is this one right here. This is 9. Yeah, so we've got A to B to C is 9 to 25 to 15. Now remember what the question asks us for. It says show that A plus B to the ratio B plus C is equal to 70 to 20. But now we have A, B, and C. So let's work these out. We need A plus B first. A plus B is going to be 9 plus 25. This is equal to 34. That's fine. We need B plus C, which is going to be 25 plus 15. And this is equal to 40, right? So now we can set the ratio of A plus B, sorry, to B plus C, right? Is just going to equal these numbers here, 34 to 40. And we can simplify this by dividing by 2 to get 17 to 20. That's exactly what they wanted, isn't it? So we've done it. And that will give us the 3 marks. And that's question 18. Okay, so question 19 says ABC is a right angled triangle. It says AB is 9.3 centimeters correct to the nearest millimeter, and AC is 12.6 centimeters correct to the nearest millimeter. I will need to calculate the lower bound for the size of the angle marked X. Okay, so this is a bounds question, right? So straight away, what you want to do is you want to get your upper and lower bounds for whatever sides they've told you have been rounded, right? Now, firstly, they've given AB in centimeters and it says correct to the nearest millimeter. Now, when this happens, right, what you can do is just say to yourself, okay, well, fine. Well, how many millimeters are there in a centimeter? There are 10. So I'll just do this here. Oops. There are 10 millimeters, right, in 1 centimeter. So it says nearest millimeter, which is 1 millimeter. So 1 millimeter, we would just divide by 10, which is the same as 0.1 centimeters. So when they say nearest millimeter and it's given in centimeters, you can just replace this with nearest 0.1 centimeters, right? And essentially that just means that you're rounding this number to 1 decimal place. Now, what I like to do with these types of bound questions, I like to draw a little table just to help me remind me of what I need to do to get the bound. So I'll just do a little table like this actually. Let me just get it like here. Get like a little one like this, and then do like this essentially. I just draw lines like this here. And I'm going to call these my units here. Now I'm going to call this ones, right? My ones unit, which is just 1. This is my tenths, so I'm going to do 1 over 10, which is 0.1. And this is hundredths and so on and so forth, right? Which is going to be 0.01, and then thousandths, and then so on and so forth, right? Which is 0.001. Now, we need to round this to the nearest 0.1 centimeters or 1 decimal place. I look at my table and ask myself, well, where is that? That is right here, right? So all you're going to do is you're going to half this number. So I'm going to do 0.1 divided by 2, and this is 0.05, right? Now to get the upper lower bound, all you're going to do is add and subtract this number from your original. So for example, if I wanted the lower bound for AB, I'll call it AB low. This is just going to be 9.3, take away 0.05, and this is 9.25. And then the upper bound is going to be the same thing but added, isn't it? So there's going to be, whoops, need to put plus there, plus, and then 0.05. This is going to be 9.35. So these are upper lower bounds for AB. we can do the exact same thing for AC. So I'll just do it here. AC, again, it's correct to the nearest millimeter, which is going to be the exact same thing we've just done. So I'm going to say AC low is going to be the original, which is 12.6, minus, need a minus here, minus 0.05. This is going to be 12.55. And then the AC upper, we're going to add it instead. 12.6 plus 0.05 is going to give me 12.65. So now we've got our upper and lower bounds for A, B, and AC. Yeah? Now, the question asks us for the lower bound for the size of the angle marked X. We're dealing with a right angle triangle. Well, how could we get the angle X? It's just trigonometry, isn't it? This is just SOHCAHTOA, right? So what you want to do, I'm going to write the acronym SOHCAHTOA. Write the acronym SOHCAHTOA here. What you want to do is you want to label your right angle triangle first. Now remember, this is the angle here. The side opposite the angle is always called the opposite. The side opposite the right angle is always the hypotenuse. And it leaves the adjacent, which is always in between the right angle and the angle here. So this is our angle. This is our triangle labeled. Now we need to figure out the size of the angle. So how do we deal with SOHCAHTOA? Well, firstly, you're going to ask yourself, we're looking for an angle, right? So we need two sides. Well, what sides have they given us? We've got 9.3, which represents the opposite. So I'm going to highlight O here. And we've also got 12.6, which represents the hypotenuse. I'm going to highlight H here. So it has to be SO that we're using, right? So it can't be cat, can't be TOA. So we know we're using SO. So now I'm just going to put this here. We're using SO. And we know that SO means that the sine of the angle is just equal to the opposite divided by the hypotenuse. Now, if I plug in everything that I know, I've got sine of the angle, which is X, right? This is equal to the opposite divided by the hypotenuse. And this is, opposite is AB and hypotenuse is AC. So essentially it's AB over AC, right? Now, because we're looking for X, right, I need to do the sine inverse, don't I? So I'm going to just do the sine inverse, like this here, sine inverse of AB divided by AC. Now, we are here, we need to figure out what X is, the lower bound for X. So I'm going to call this X low, right? Now, we've got this sine inverse here. Now, this answer X is dependent on what is in this fraction here. And that comes back to our boundaries. We need to choose a combination of boundaries which will minimize this angle here. Now, we're dealing with a fraction. How do you minimize a fraction? Well, remember, the numerator is what you multiply by. The bigger the numerator, the bigger the answer, the overall value, right? So if we want this to be as small as possible, we would want the numerator to be the smallest, right? And the numerator is AB. So what I would do is I'm going to choose AB low, right? So I'm just going to write this here. Before I put the numbers in, I'm just going to put the boundaries we're using, AB low, right? And then now the denominator. Now remember, when you're dealing with a fraction, the larger the denominator, right, the smaller the value overall, right? Because you're dividing by more, right? So if we want this to be as small as possible, we want the denominator to be as big as possible, which means that we have to choose the upper bound for AC, right? So I'm just going to put AC up here, right? AC up, like this. Let me just make this a bit neater, actually. So it's in a bigger bracket like this. That should be AC up, like this. And what that means then is, well, we're just going to plug in those values. So it'd be the sine inverse of those values there. Now, AB low was 9.25, 9.25, and then AC up is 12.65. So to get the lower bound, we're just going to do the sine inverse of 9.25 divided by 12.65. So I get my calculator and put this in. I'll do it here. Be the sine inverse of those two, so 9.25 divided by 12.65. And this gives me 46.989, 46.989, which if I round that to three significant figures, this is just going to be 47 degrees. So the answer is just 47 degrees. And that's it. And that'll give you the 3 marks for question 19. Okay, so question 20 says ORT is a triangle, right? They've told us that O to T is equal to A and R to T is equal to B. These are vectors. It says M is the point on OR such that the ratio of O to M to R is 2 to 3. And we need to express M to T in terms of A and B. Give your answer in the simplest form, okay? So what I'm going to do is I'm just actually going to screenshot this diagram again, just so I can annotate it, because I don't want to use that one. So I'm going to just screenshot it here, paste it here, just put it underneath here, and then just minimize it here. And we're going to use this one for our annotations. Okay. So what do we know? They've told us, now firstly, they've told us that M is on the point, M is the point on OR such that this ratio is 2 to 3. Now, whenever you see this type of ratio when you're dealing with vectors, you always just write it as a fraction of the entire length. So for example, we've got O to M, right? O to M, we've got M to R, and this is in the ratio 2 to 3, meaning that the total amount of parts together is going to be 2 plus 3, which is equal to 5, isn't it? 5 parts here, right? So in our case, what we can do, let me just zoom out a bit so we can see the workings as well, right? What we can do is say, well, this part, which is O to M, right? This is going to be 2 parts out of 5, isn't it, right? So I'm going to write this as 2/5, like this here. And then this one, which is M to R, I'm going to write this as 3/5, like this. This is going to be 3/5 here. That's the first thing I'm going to do. Now, we need to express M to T in terms of A and B. Now, what I like to do before I start dealing with algebra, right, is I actually want to label that vector on my picture so I know exactly where it is I need to go to get there. So I'm going to draw a line from M to T. It's going to be something like this here. Like this here. And this is M to T. Let me just straighten up this part as well. Yeah. Okay. So this is M to T right here. Of course, M to T right here. Now, how do I go from M to T? Well, there's actually 2 ways. I could go along this one and then go along B, or I could go along this one and go along A, right? O to T. Now, it doesn't matter which one you use, right? Just as long as your algebra is okay, then you'll get the same answer. But what I'm going to do is I'm going to go along the green one, and then I'm going to go along this one here, right? It's way too thick. Let me just decrease the size. So this one here. Yeah. So our answer, remember, M to T is what we're looking for. From the picture, we can see that M to T is just equal to M to R plus R to T, right? So it's our job to figure out what these 2 vectors are, add them together in terms of A and B, and that will be our answer. Now, what do we know? Firstly, R to T is given to us. It's B, right? R to T is B. So I can just put this, I can say M to T, right, is equal to M to R plus B. And this is our answer so far. Now, because we've got B, R to T, we need M to R. So our job is to figure out what M to R is. Now, if I have a look at this diagram here, M to R is 3/5 of this line here, right? It's 3/5 of this entire line, O to R. So I'm going to write that out first. I'm going to say M to R is actually equal to 3/5, right, of this line here, O to R. And I can write this as a vector, right? So what I need to do now is work out what O to R is and then just do 3/5 of it, and that will give me M to R. And then we can put that into the final formula and that will be our answer. So O to R, what would that be? Going to get this diagram one more time, just so it's clear. So I'm going to copy this here without the annotations. Whoops. To go back down here. Yeah, right here. So we just put this here and then let me paste this here. Go back. Okay, so going to get this diagram again. Now, O to R, because that's what we're looking for. Whoops, what's going on here? To go down. Oops, apologies for this. Whoops, I've gone too far. Okay, we're here. Okay, hopefully it doesn't play up anymore. So O to R is what we're looking for. Now, O to R, we can see is, I'll do it in a different color actually. It's this one right here. This is O to R right here, right? This vector here. Now, how do I go from O to R? Well, if I look at the picture, I can see that O to R, right, is just equal to going from O to T, and then plus T to R. That would be how we go from O to R, right? Now, O to T is quite clearly A. It's given to us right there. So I'm going to point A here. I'll just zoom in a bit more so it's a bit clearer. So that's A. And then, so I'm going to write this here. This is O to T. And then we need to go from T to R, which is the opposite of going from R to T. So it's going to be a minus B here, isn't it? So I'm going to put a minus B here. So it's going to be plus and it's going to be minus B, which is the same as A minus B. So now we know what O to R is. Why is this helpful? Because remember, we need M to R, which is 3/5 of O to R. So I could say from here, we could say therefore, the vector M to R, right, is just going to be 3/5, but equals better than that. Oops. Okay, I think that's fine. 3/5 of O to R, which is A minus B. So actually I can write this here and say that M to R then is just equal to 3/5 multiplied by A minus B. So I'm just going to expand this bracket. It's going to be M to R is going to equal 3/5 A minus 3/5 B, like this here. So now I've got M to R. Now remember what the question was asking us for. It was asking us for M to T, which we said was M to R plus B. But now we have M to R, so we can actually just finish this off. So I'll do it right here. I'll do it right here. So we could say from here M to T, right, is actually equal to M to R, which we now know is 3/5 A, 3/5 A minus 3/5 B, and then plus B, isn't it? So we just need to simplify this. So I'm going to do this right here. Just zoom in a bit more. So tidying this up here, I've got M to T, right? And there's only one term of A, so I'm going to leave it as 3/5 A. That's fine. 3/5 A. And then I've got to do minus 3/5 B plus B. Now, whenever you get this type of question here, minus 3/5 plus B plus 1B, right? I'm going to just do this here, just so it's clear. I've got minus 3 over 5B, right? Plus B, which is just the same as 1B, essentially. So this here, minus 3/5 plus 1, how would I do this? Minus 3/5 plus 5/5, right? And then this is just equal to, they have the same denominator. This is just going to be 2/5, right? Minus 3/5 plus 5/5 is just 2/5. So we can actually say that the minus 3/5 B plus 1B, which is the same as 5/5, is just the same as 2/5 B. Meaning that this here is just going to be a 2/5 B on the end. And that will be your final answer here. So the vector M to T, I'll do it right here, is just going to be 3/5 A plus 2/5 B. And that's it. And that will give you the 4 marks. Okay, so question 21 says, here is the graph of y equals f of x, right? And for part A, it says, on the grid below, we need to draw the graph of y equals f of x minus 4. So this questionnaire is just typical graph transformations. And there are quite a few of them that you need to know off by heart because it's not given to you in the exam, which I'll put a graphic up for you right now. So yeah, doing this one, we can see that we've got y equals f of x take 4. Now, what graph transformation does this represent? It's on the outside of the function, so it's going to be a vertical translation. So it's either going to move up or down. Because it's a minus 4, it just means that you're going to shift the graph 4 units down. So what I'm going to do as well, let me just zoom out so we can see both of the graphs here. This is where the graph originally is here. It's just going to be shifted 4 units down. So 1, 2, 3, 4. So it'll be here, and obviously this will be here as well. And then you're just going to just draw the shape just 4 units down. So essentially, it's just going to look like this. Let me just see where it is again. 1 above, so it's going to be 3 below. So it's going to be right here. So it's just going to be like this essentially. And obviously, you can use your ruler just to make sure it's really neat. But it's just going to be like this essentially. That. That. Or to be fair, actually, I think I can actually use ink to shape on this. Let me try again. There, there. Does that work? Yeah, it does. That's perfect. Brilliant. And this would be where your new graph is. This graph here is y. Whoops. Put this here. This graph here is just y is equal to f of x minus 4. That will be your answer for part A. Part B says we need to sketch the graph of y equals f of minus x. Now again, this is another graph transformation. If you want to sketch f of minus x, then all you're doing is you're just going to reflect your graph in the y-axis, right? So essentially, you're just multiplying all of your x coordinates by minus 1, right? The minus is happening inside, so it affects the x coordinate. So what I'm going to do is I'm going to sketch the original graph, right? Which is going to be, was like this. Let me just double check what it was. Yeah, it was like that, wasn't it? So it's going to be like this. So I'll just do it here. That. That is the original graph. I'm just going to straighten it up a bit. So it's just a bit neater. So you get an idea. So it's pretty much like that. You guys get the picture. And then the new graph is just going to be a reflection. I'll do it in green just so it's clear. Yeah, it's going to be like this. Like this here, like that there, like that there, and then like that there. Hopefully that should do it. Yeah, that's perfect, isn't it? So I'll just straighten this up a little bit so it goes right there. And then just widen it a bit. Oops. And then just lift it up. Yeah, that looks perfect to me. And then this graph here, this is going to be the graph of this is going to be the graph of y is equal to f of minus x. And that's it. And that's question 21 finished. Okay, so question 22 says, there are only blue pens and red pens in the box. The number of blue pens is 4 times the number of red pens. It says, Rita takes at random 1 pen from the box. She records the color of the pen and then replaces it in the box. Rita does this n times, where n is greater than or equal to 2. And we need to write down an expression in terms of n for the probability that Rita gets a blue pen at least once and the red pen at least once. This is only 2 marks, right? This is definitely tricky. When I first saw this question, I was thinking this is definitely a bit mind-boggling for sure. But what you want to do is essentially just try and ask yourself, what are the events or scenarios whereby the probability that they're asking you for can happen, and try and see if you can formulate some patterns. So we're going to start with this. They've told us that the number of blue pens is 4 times the number of red pens. Now, whenever you see this type of expression here, you could always create this, we can formulate this into a ratio, right? So I'm going to just write B and I'm going to write R here. Now, if the number of blue pens is 4 times the number of red pens, that means that for every 4 blue pens, there's 1 red pen. So we can say that the ratio of B to R is 4 to 1. Now, why is this helpful? Because this actually allows us to work out what the probability is of both of them. So what I'm going to do is I'm going to put this here, bring this here. Yeah. So the probability of me getting a blue pen, for example, right, is just going to be, how many parts are there for blue? 4 divided by 4 plus 1, the total, which is 5. And then similarly, the red is equal to 1 over 5. Okay, so now we know the probability of us getting a blue or a red pen when we take a pen. Now, let's look at a bit more of the question. It says she takes out random 1 pen from the box, she records the color of the pen and then replaces it, right? And she does this n times, where n is greater than or equal to 2. So what I would do is try and formulate a pattern, right? We're looking for the probability that it gets gets a blue pen at least once and a red pen at least once, which is pretty much the same as 1 of each, right? So for example, she does this n times, where n is greater than or equal to 2. So what I would do is try and formulate this for n equals 2 and see if I can formulate a pattern, right? So for example, if I say n is equal to 2, right? Now, what would the probability be for each of these scenarios? She's taken a pen and then replacing it. One thing that can happen is that she gets all blues, right? For example, so I'm going to say probability of me getting all blues, for example, right, will just be equal to 4 over 5 multiplied by 4 over 5, isn't it? Remember, it's the probability of a blue and a blue. So we can just write this as 4 over 5 all squared. You're going to see why I'm writing it like this. Now, similarly for all reds, right? For all reds, it's just going to be 1 over 5 times by 1 over 5, which is 1 over 5 squared. Right, this is 2 scenarios whereby she can pick up a pen, right, when she does it twice. Now, what is the other scenario? She could either get all blues or all reds, or she could just get 1 of each, isn't it? So I'm going to say the probability of at least 1 of each, right? At least 1 of each. In this case, because it's 2, it's just 1 of each, isn't it? Because it's only 2. But I'm just going to put at least 1 of each because it's just going to be the same thing. At least one of each. Well, how can this happen? Excuse me. How can this happen? So we can either, for this one, we can either get a blue and then a red, right? Or we could get a red and then a blue, right? So what would these be? Let me work this out. Probability of blue and the red. Well, blue is 4 over 5, and then red is 1 over 5. So it'd be 4 over 5 times 1 over 5. And then, or remember, we know it's plus when we deal with probability. And then this is going to be the opposite, isn't it? It's going to be 1 over 5 times by 4 over 5. And now if I put this in, this is going to be 4 over 25 plus 4 over 25 again, which is the probability of 8 over 25, isn't it? Now, why is this important? Because we're able to formulate a pattern. So I'm going to just put this here because we've done this. This is for n equals 2. So I'm going to say for n equals 2, we're going to say that, for example, the scenarios that this can happen is either you get all blues, which is, I'm going to write this here, probability of all blues. All right, just all blues, or all reds, right? Just write this out. All reds, or at least 1 of each. At least 1 of each, right? Now, because these are all of the scenarios whereby this can happen, we would expect that when we add these probabilities together, it should give us 1 because it's the total probability space. So let's see if that works. All blues we can see is 4 over 5 squared, plus 1 over 5 squared for all reds when you do it twice, and then plus 8 over 25, right? I don't need a bracket to be fair. So I'll put 8 over 25 like this. And then if I put this into my calculator, when I put this in, I should expect to get 1, right? That is critical. So let's just see if we get that. Squared plus 1 over 5 squared. This here plus 8 over 25. Like this. This gives us 1, right? Which it does. This is important. This is very critical because now we can actually formulate an expression algebraically for the probability of at least one of each, which is what they're asking us for. Now remember, I'm going to highlight this in blue here, like this. Highlight this in blue. This here is the at least one of each. Now, if I rearrange this, right, if I rearrange this formula, we can say that 8 over 25, right, is just going to equal 1 minus the probability of all blues, which is 4 over 5, all squared, and then minus the probability of all reds, which is 1 over 5, all squared, right? And this is for n is equal to 2. Now, we can formulate a pattern because remember, it says she does this n times where n is greater than or equal to 2. So for example, I'm going to write this here. This is at least one of each, right? Probability of at least one of each. One of each. Now, for example, if it was n is equal to 3, for example, based on what we can see here, right? I think I've got a bit of room. Yeah, I've got a bit of room. If it was n is equal to 3, then it's going to be this here. I'm going to write this. I'll do it here, actually. So the probability of, I'll just write at least one of each. One of each. If it's for n is equal to 3, like this. Let me just put this here, actually. I'm going to put this here. This is here. This is for n is equal to 3, right? Now, based on this, it's just going to be equal to 1 take away. Now, remember, this is for n is equal to 2, right? Let me highlight this so it's clear to see. This is for n is equal to 2, and this is a square here. This is a 2, and this is a 2. So in this one, it's going to be 4 over 5 to the power of 3 minus 1 over 5 to the power of 3. This is for n is equal to 3. Now, if I extend this for any value of n, which I do n is equal to n here, right? Then the probability of getting at least one of each color, one of each, this is just going to equal, well, again, the pattern here, this is n equals 3, this is a 3 here, this is a 3 here. So we can see that the answer is just going to be 1 minus 4 over 5 to the power of n minus 1 over 5 to the power of n. And that will be your answer here. And yeah, it's pretty tricky for sure. I think it should definitely be a bit more marks. You guys can let me know in the comments what you think. But yeah, this is the answer for question 22. And that will give you the 2 marks. Should be more, but what can we do? Okay, so question 23 says, here are 3 similar triangles, ABG, ACF, and ADE. It says ABCD and AGFE are straight lines, and it says AB to BC to CD is in the ratio 1 to 2 to 3. And we need to show that the area of ABG to the area of BCFG to the area of CDEF is equal to 1 to 8 to 27. This is a 3 marker. It's the second last question. So definitely going to be a bit tricky, but similarity, ratios, it's always the same type of thing. What I'm going to do first is I'm going to actually just draw out those triangles that are similar, because from there maybe I could figure out maybe the ratios of the lengths, areas, and so on and so forth, right? So let me do that first. So ABG is the first one. So I'm going to put this here. I'm going to just draw a triangle like this here. I'm going to call this ABG. So G is this one. G is here, and then B is here, like this. And then what I'll do actually is I'll just copy this triangle and just make it slightly bigger. So I'll just copy this here, like that. And I'll just make it slightly bigger because it's similar, isn't it? So let's just say this triangle now is the second one, which is ACF. ACF. So it's going to be ACF. And then the last one, which is the biggest, just paste. I'll paste another triangle here. And I'll make this bigger than those two. So it's like this, essentially, isn't it? Yeah. Now I'm going to label this to be DE, isn't it? Yeah, ADE. So these are our triangles here. Now, because these are mathematically similar, my job is to maybe try and figure out the lengths of them, the areas, and so on and so forth. Now, what do we know? They've told us that the ratio of A to B, B to C, and C to D is 1 to 2 to 3. Now, if I put this here, right, well, A to B is 1, right? B to C is 2, and C to D is 3, right? This is what the question tells us. Now, if I attempt to label this on our diagrams, right? A to B is 1. I'm going to put this here. And A to C, which is this one right here, is going to be 1 plus 2, isn't it? It's going to be 1 plus 2. There's going to be a 3 here. And then A all the way to D is going to be 1 plus 2, which is 3, plus another 3, which is 6, right? So we've got the lengths here. Now, how is this helpful? Well, remember, when you're dealing with similarity questions, right, there are 3 types of scale factors. There's the length scale factor, sorry, the first one. There's the area scale factor, and there's the volume scale factor. Now, we're dealing with a 2D shape, right? It's not 3-dimensional, so we don't need the volume for this question, but it's just always good to have that in mind, right? So what we can do is say, well, we can actually work out the ratio of the lengths, right? In terms of scale factors and so on and so forth. So I'm just going to put this here. I'm going to say that the ratio of the lengths, right, of these triangles, right, is quite clearly going to be 1 to 3 to 6, right? Now, going back to what I said before about the different types of scale factors, right? If you have the ratio of the lengths, you can work out the ratio of the areas just by squaring it. If you know the ratio of the lengths and you want to work out the volume, then you cube it. Again, this is not a 3D question, so we're not going to need the volume. But what we can do is work out the ratio of the areas, right? So I'll just do this here. I'm going to write ratio of the areas like this, right? All you're going to do is just square these. It's going to be 1 squared, 3 squared, and 6 squared, right? And this is going to be 1 to 9 to 36. So now we have the ratio of the areas. And why is this helpful? Because we need the ratio of ABG, BCFG, and CDF, which are areas, right? So this is definitely on the right track. Now what I'm going to do, because I'm running out of room, I'm just going to minimize this here. So let me just highlight all of this. And I'm just going to minimize this and put this here. Okay, that's fine. I think that's okay. Yeah, brilliant. So this is where we're at. We've got the ratio of the areas to be 1 to 9 to 36, meaning that we can actually just plug these in. I'm going to put this in green. This area here is 1. This area here is 9. This area here is 36. Now, we need the area of ABG to the area of BCFG to the area of CDEF. Now, how do we do this? Well, the first one is very easy. ABG is just a triangle here. So I'm going to say areas now. Areas, right? And I'm going to say ABG, we know is just equal to 1, right? That's 1 right there. That's fine. Now we need BCFG. I'm going to write BCFG here. I need this one. Now BCFG, if I go back to the original diagram, right, BCFG is just this part of the diagram. And as you can see, that's just the lower section of the triangle ACF, the second triangle, right? So what we can do here is I'm actually in our diagram, right? I'm going to split this into 2. I'm going to put a line here, and I'm going to rub out this 9, right? Now, by the way, this 9 is the area of the triangle, which I'm going to put on the outside, right? But I'm going to split this. Now, we know that the top part, which I'll put in yellow, right? This part here. So this is not yellow, that's green. Top part, which I'll put in yellow, right? This has an area of 1. It's just ABG, isn't it? Now, the bottom half, right? Well, this is BC. What is it again? It's BCFG, isn't it? Yeah, this BCFG, the lower part, like this. Well, if the entire area is 1 here, right? Then, well, 1 plus what will make a 9? It has to be 8, right? So this area here is going to be BCFG, isn't it? Right? If we look at our picture. So I'm going to put an area of 8 here. This is 8. Now, remember, we need the last one, CDEF. Well, where is that? Let's go back to our original picture. CDEF is this one. Actually, let me use a different color. I'll use green. This one right here. This is the area of CDEF, isn't it? We need this one here. So I'm going to go to the last triangle because this is just the lowest section of the largest triangle. So what I'm going to do now is I'm going to split this triangle into 3 parts. This is going to be the top part, right, which we know is 1. I'm going to label this as a 1 right here. Oops, that's not yellow. Need a yellow. Got yellow here. This is 1 right here. And then, oh yeah, as well as that, let me get rid of this 36. I'm going to put the 36 on the outside just so we know, remember what the area is, just 36. I'm going to put a line here. And we know from this part, this is 8, isn't it? So I'm going to put this in blue. This is going to be 8 right here. Now remember, the entire area has to make 36, and we have 1 and 8. 1 and 8 is 9. So we need to do 36 take 9, which is just 27, isn't it? Meaning that this area underneath here is, put in green. This area here is 27. So now we could say, well, the area of CDF, which is the last one, CDEF is 27. So therefore the ratio is just going to be 1 to 8 to 27. And it's actually given in this diagram here, isn't it? And that will be your answer. And that will give you the 3 marks. Okay, so question 24 says the diagram shows 8 identical regular octagons joined to enclose a shaded shape. It says each octagon has sides of length A. Find in terms of A an expression for the area of the shaded shape. Give your answer in the form P multiplied by 2 plus root 2 multiplied by A squared, where P is an integer. You must show all your work in. Now, this is a 5 mark and it's the last question of the exam, so it's definitely very tricky. Now, what you want to do with a question like this is just break it down into pieces, right? Now, we're looking for a shaded area, which is fine. But as well as that, they've also told us that we're dealing with regular octagons, right? In other words, polygons. So another thing that my mind is going to go to is polygons, sum of interior angles, exterior angles, interior angles, and so on and so forth, right? Now, what I'm going to do is they've told us that each octagon has lengths, sides of length A. So I'm going to label that there. So for example, this is going to be an A here. It's going to be an A, and so on and so forth, right? And that means that along our shape, right, the shape that we're looking for, we're going to have A's, aren't we? Like this. Okay. Now, what I want to do is I want to essentially break down this shaded area, right? Because if I can break it down, I could work out pieces and parts of it and then put them together, and that could help me answer the question. So what I'm going to do, let me just rub this out because I'm going to screenshot this and then I'll put the A's back. So I'm going to screenshot this shape here. Oops, let me screenshot so I get everything in actually. So I'm just going to screenshot like this here. Okay, that's fine. So I'm going to screenshot this here. I'm going to put this in. I'm going to say that this is my area here. Okay, so this is the area that we're looking for, right? And essentially, I want to break this down. And well, the way I can break this down is if you think about it, right? If I draw lines like this here, and I draw a line like this here, like that, I draw a line like that there, and a line like that, then we actually just have a potential square or rectangle, right? Could be a square, could be a rectangle. We'll find out, but it's going to be equal to this shape here, like this, like that, and then I would add on those 4 triangles that are pointing out. So I'm going to just draw a triangle like this, like that. Okay, let me just do it a bit better, just so it's the right way. So just do it like this, like that. Okay, that's fine. We'll do another one like this, like that's fine. And then these are all meant to be the same. So like that there, and then do one more like this. Okay. These are meant to be the same, so it does look a bit lopsided, but you guys get the picture. So we've broken down our shape into the area of this rectangle or square, we don't know yet, and these 4 triangles. Yeah. So what I'm going to do is, actually what I'll do, I know what to do. I'm going to copy this a couple of times and then rotate it. So copy, and then copy, and I'll just rotate them because it's just for the picture. So I'm going to rotate this way. Rotate, it's going to be to the right, and then that's fine. So I'm going to delete this one and put this one here just so it's clear to see. So that will go there. And then this one I'm going to rotate to the left, and then that will be like that. So I'm going to delete this one, put that there. So that's fine, put that there. And then the last one, I'm going to rotate this twice. Rotate this to the right, and then one more time. Rotate this way, so I get this here. So I'm going to delete this and then put this here. Okay, that's much better. It's much better. Okay, let me get rid of those 2 eyes. Looks like a person smiling. So let me get rid of those. Okay, so we've got these here. We need to work out these 2 areas. Now, remember what they told us? They told us that we're dealing with a regular octagon, right? So let's go back to our diagram here. Now, we know that with octagons, they have interior and exterior angles. And one thing that you should remember is that the formula for the exterior angle of a regular polygon, sorry, is just going to be equal to 360 degrees divided by the number of sides. So what we can actually do is work out the exterior angle for these octagons here. So I'll do this here. So I'm going to do this. It's going to be 360 divided by 8. It's equal to 45 degrees, right? And what that means essentially is that, for example, I'll just do it here so it's easy to see. So for example, this is going to be a 45-degree angle. And then that means that the interior one is 135, isn't it? And so on and so forth. Now, how does that help us? it helps us because, for example, if I do the exterior angles for these two right here, right, remember this is going to be on the outside, this is going to be 45 degrees, this is going to be 135, like that. It's going to be the exact same on this one here. This is 45 degrees, it's going to be 135 here, like that. Well, we've got two 45-degree angles, meaning that this corner here is a right angle, right? Now, essentially what we could say then is from this, we could just say, well, all of these here in the corners, right? These are all right angles, like this, like that, like this, like that, and like this. And we also know that each of these lengths, right, are A's. Remember, they told us that each octagon has side lengths of A. So essentially what we have here is we've got a right angle triangle with the base and the height to be A, right? So I'm just going to put this here, I'm going to put this here. So what we can actually do is let's label what we have here. Remember, these triangles, I'll just do this here, by the way, just so it's super clear. These triangles here, these triangles like this, these triangles like this, they all have a base and height of A, and they're all right angle triangles. So I'm going to just put this here. I'm going to put this there. 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 And we know that the base and the height are all A's. So I'm going to put this here, put this here, put this here, and put this here, and then put this here, and then put this here. Now, with that being said, remember, we need to find the area in terms of A. So we can actually figure out what the areas are of these triangles. Well, the formula for the area of a triangle is just half times base times height. So I could say that the area of one of these triangles, right? One of these triangles is just going to be equal to A times A, base times height, divided by 2, which is just going to be A squared over 2. Now, we have 4 triangles we need to calculate. So all I'm going to do to figure out what the area of 4 triangles are is I'm just going to times it by 4. It's going to be 4 times A squared over 2. And this is just going to be 4 times a half is 2. This is going to be 2A squared. So actually, we've actually worked out one part of the answer. We know that the 4 triangles make 2A squared. So we're going to leave this for now, right? Now we need to work out the area of this shape here, which is either a rectangle or a square, right? We're not sure yet. Now, we've got this diagram here again. So what I'm going to do actually, because it's good, I'm going to put these here. This is going to be an A here. It's going to be an A here. It's going to be like this. It's going to be another right angle like this here. It's going to be A. It's going to be A, and so on and so forth, right? Now, what we have here is we've got these triangles like this here, and because this is a right angle triangle and we know the base and the height, we can actually just use Pythagoras to work out the hypotenuse, right? Not too bad. So I'm going to do Pythagoras here for this one. I'm going to draw this triangle here again. I'm just going to draw it here just so it's clear. We draw like this. I'm going to do it upright. And then we're going to say, well, fine, this is going to be an A here, this is going to be an A here, and I'm going to work out this length here. And we're just going to use Pythagoras, which means if I call this C, then this is going to be A squared plus A squared is equal to C squared, isn't it? This is just A squared plus B squared is equal to C squared, but A and B are both A, right? So doing this is going to be 2 lots of A squared is equal to C squared. And that means that, well, C, which is what we're looking for, is going to be the square root of that. So it's going to be 2A squared all square root, and it's equal to C. Now, we need it in terms of A. So let's use our surd laws, right? We know from our surd laws, when you have a product inside a surd, we can split them separately. So I can actually write this as root 2 and then root A squared, and this is equal to C. So meaning that this is just root 2. And then from our surd laws, if I square something and then square root, it's just going to give us the thing underneath. So it's just going to be root 2 and then A. And this is equal to C. So I'm just going to replace this here with root 2A. Now be careful, that root is not on top, is not part of the A, it's just a 2. So it's root 2 times A, meaning that each of these here is just root 2 times A. And if you think about it, these are all going to be the same, aren't they? So actually what we have is we have actually another octagon inside this shaded area where all of the lengths are root 2A. Now, this is helpful, right? Remember, we're trying to figure out the area of this rectangle or square. So let us figure out what this is. So got this here. This is one part of the square, one part of the height, sorry, like this here. And so is this one. We know that these are all A because this is part of the regular octagon on the outside. So if I apply this here, I'm going to put this part like this. I'm going to put this part like this here. And these are both A's, like this. This is an A, and that's an A. And then the part in the middle, right, this one here, well, remember, this is just one of the lengths of this new regular octagon that we figured out, which lies inside the shaded shape, right? And these are all root 2 A's. like this. So essentially what I can do, let me move this equal sign a bit this way, like this. I'm going to put this equal sign here, and I'm going to call this side in the middle here root 2a, like this. So we actually have the height of this rectangle or square, right? Now, again, this has to be a square actually, because if you think about it, it's the exact same for this part here. This is an A, this is an A here, right? Which will represent this part here. It's going to represent this part here, and then this part here, like that. These are both A's. Point A here, and an A here. And then in the middle, we've got this one, right? Again, this is one of the other lengths of the regular octagon that we found inside. This is root 2a. So therefore, this is going to be root 2a. So you can see the base and height are exactly the same. So this is actually a square. So now, this is very helpful because we need the area of this square. We've got the base and height in terms of a, which is really good. So we could just say then, well, firstly, let's work out what this is actually going to be when we add them all together. So I'm going to say length. I'm going to say height actually. Height and base of square, because they're the same thing. Height and base of square. This is going to equal the two parts in blue, which is going to be a plus a, these two parts in blue, plus the part in green, which is root 2a. Now, a plus a is 2a, and then we have root 2a here. So essentially, our square, I'll do it on this page here. Do it on this page. I'm going to do it one more time. Like that. What do we know? We know that the base and height is 2a plus root 2a. So I'm going to do this here. It's going to be 2a plus root 2a. And it's going to be 2a plus root 2a. And this is very good because remember what we needed to show? We need to give answer in the form of p2 plus root 2a squared. And we've got a 2 and a root 2 here. So this is definitely along the right track. So we need to work out the area of this now. So I'm going to say the area of this is just going to be, we're just going to times these together, aren't we? It's going to be 2a plus root 2a. And then multiply by the same thing. This here. And then now we need to expand. We've got 2a and a 2a, which is 4a squared. We've got a 2a and a root 2a. So the 2 and the 2 root will make 2 root 2. And then we've got a and an a, which will make an a squared. Like that. And it's the exact same thing for this one, isn't it? It's the exact same two terms. So it's going to be the exact same answer. 2 root 2 and then a squared. And then the last one, we've got root 2a times root 2a. What I like to do when I do it with surds, these types of ones I'll just break down. So it's going to be, the last one's going to be root 2a times root 2a. The root 2 and the root 2 will make a 2. The a and a will make an a squared. So the last term is just 2a squared. Now tidying this up, well, we've got a 4a squared and a 2a squared that will make 6a squared. And then we've got 2 root 2 a squared plus 2 root 2 a squared. It's 2 lots of 2 root 2, isn't it? Which is going to be 4 root 2. 4 root 2 a squared. So now we have the area of the square. I'm going to write area of square is equal to 6a squared plus 4 root 2a squared. Now remember what we were trying to figure out. We were trying to figure out the area of the shaded shape, which we broke down initially. We said it's going to be the area of the square, which we now have, plus the area of the 4 triangles, which we had a long time ago. So the final answer is just going to be those two areas added together. So I'm going to say, therefore, area of shaded shape is going to be equal to the area of the square, which is 6a squared plus 4 root 2a squared. And then we're going to add the area of the 4 triangles, which is 2a squared. So I'm going to put this here. And what I'll do, just so it's super, super clear, let me just put this down a bit. I'm just going to put this, I'm going to write this as, I'm going to say this area of the square. And this one here is going to be the area of the 4 triangles. Okay, so now finishing off then, we can just say, well, let's tidy this up. I've got 6a squared plus a 2a squared. That's going to be 8a squared, like this. And then I've got 4 root 2a squared, like this. This is our answer. Now let's have a look at the actual form that they wanted it in. They wanted it in this form here. So I'm going to screenshot this here. Okay, so we've got these two terms here. and they've got brackets, right? So it's definitely something has been factorized. So what I'm going to do first is I'm actually going to factorize this. Whoops, go back here. Apologies for that. Let me go back to question all the way down here. Okay, so we're here. Let me just go back. So we're here, nearly done. Okay, so dealing with this now, we need to factorize, as I was saying before. So I'm going to take out, what can I take out? I can take out a 4 for sure. And I can take out an a squared, can't I? I can take out a 4a squared. And what will that leave us with in the inside? 4a squared, I need to get to 8a squared. I'm just going to put a 2 here. And then I need to get to 4 root 2a squared. And I've got 4a squared. I just need a root 2. And this is good because we've got that bracket of 2 plus root 2. Now, they've got a number at the front and the a squared on the end. So all that means for me is I just need to put 4 here at the front and then 2 root 2 and then the a squared on the other side. So therefore, this is our answer. 4 times 2 plus root 2, a squared. And our value for p is just equal to 4. And that's it. Pretty tricky to be fair. But yeah, this is the last question of paper 2, and it's 5 marks, so we've done it. Hi guys, Daniel here. Hope you guys are doing well. So yeah, we made it to the end of paper 2, and yeah, definitely a tricky paper, as you can see with the workings out here. And hopefully this video has helped you clear up any misconceptions for any questions you may have found a bit tricky, and it's helping you move forward and progress with your revision. And yeah, again, if you found the video helpful, then it would be great if you could like, comment, subscribe, share with your friends, share with anyone that you think would benefit from these videos. Paper 3 will definitely be on the way very shortly. It's going to be uploaded not too long after this video is uploaded. So yeah, just stay tuned. And again, thanks for all your support. I'll see you guys for paper 3. Take care. Bye bye.